Welcome to the logic videos. Today we're talking about the truth functions, how to compute them, how to think about them. So let's start with one big idea. Again, truth functionally complex propositions are propositions whose truth values are determined in a law-like fashion by the truth values of the component propositions. So far we've started off with the 5 basic truth functional complexes: conjunctions, disjunctions, negations, conditionals, and biconditionals. So the crucial thing is that every truth functionally complex proposition has component propositions, but some of those component propositions themselves can be logically complex propositions. So let's look at a couple examples. Let's imagine that I've got the following. That is, on the one hand, this is a truth functionally complex proposition. Notice, by the way, that one of its components is a simple proposition or an atomic proposition. This is a disjunction. This disjunct is C. That's a non-complex atomic proposition. However, the left-hand disjunct of this disjunction is a conditional with 2 logically simple or atomic propositions as its components. So this is a multiply complex truth functionally complex proposition. One simple disjunct, but the other disjunct is a logically complex proposition. One of the important things to see first about this, you might say, multiply complex proposition is that we have this as the main function, but then it's got component functions. The important thing to know about this is that what we do, given what truth functional complexity is that we compute the truth functions of the component propositions first to then be able to come out and compute the truth value of the overall complex proposition. So you start from the inside and you work to the outside. The function that you compute the last is what's called the major operator. It's the propositional connective that determines the overall form of a logically complex proposition. What's the overall form of this logically complex proposition? Disjunction. Notice, by the way, that this complex itself could be a component proposition of a much larger complex. So let's imagine that. Now, what is the overall form of this formula? A biconditional. This is it's a biconditional with two biconditional propositions. One of them is a conjunction, the other one is a disjunction. The disjunction has got 2 disjuncts. This disjunct itself is complex, and it's a conditional. And we could continue to nest them deeper and deeper and deeper. The crucial thing to see is that it's whatever is the last one, the least embedded of the connectives, is what's called the major operator. It's the one that you do the computation on the very last. And again, remember that this overall proposition will come out as true when and only when this side is true and this side is true, or this side is false and this side is false. If the 2 sides of the biconditional don't match up, the biconditional comes out as false. Okay, so far so good. Now, let's do a little bit of practice computation. Let's imagine that any proposition letter at the top of the alphabet is true, and all propositions at the bottom of the alphabet are false. So A, B, and C, those are going to be true. X, Y, Z are going to be false. Okay, so let's take a look. Let's give ourselves a couple of propositions to do some truth computation. So if I say not A or not B, horseshoe not C. Let's give ourselves one other one to mess with here. A triple bar Z or B horseshoe C. Okay, so let's look at these 2. So let's start with this one on the top. So again, what we have to do is compute them from the inside out. Now, because A, B, and C are all true, we're going to get little trues in there. Now that we've got those little trues in there, now we compute that whatever's the next one out. That's going to be these negations. F, F, F. Okay, So far, so good. Now, this disjunction is between these two negations. That's false or false. False or false, given the truth table of disjunction, gives me a false. So we have a false antecedent. We have a false consequent for this conditional. How's that come out? An FF. That's the bottom line of the material conditional. If you have an FF, that whole thing comes out as false. Okay, now let's look at this one. A triple bar Z. So that's a T and an F. Triple bar, do they match? No. So that comes out as false. Okay, let's look at this side. B horseshoe C. That's a true to true conditional. A true to true conditional comes out as true. So we have false or true. How's that come out? Well, that's the third line on the disjunction truth table. Either one of the disjuncts, if I say this one or this one, and this one comes out as true, the whole disjunction comes out as true. In both cases, what we did was we computed the major operator last. In the next video, we'll do a few more complex propositions for truth value computation, and then we're going to start looking at how to be able to get natural language into this formula.